production economics or production of farm commodities involve numerous relationships. There is number of relationships between resources and the products. Now, some of these relationships are simple and some are complex. So, knowledge of these relationships is essential to provide the tools by means of which problems of production or resource use efficiency can be analyzed. So, these knowledge of the relationship between inputs and output, it is necessary because based on those relationships, we'll discuss about the solutions for the problems of production or how to use resources efficiently. Now, major production relationships are factor product relationship. Factor product matlab here input output relationship. Here we use factor is nothing but input and product is the output. Then input relationship between two factors or factor relationship, or it is called as input relationship, and product means output relationship. Between two products, what is output, what is the relationship? So these are the three major production relationships which we'll see one by one. First we'll see about the factor product relationship. In this we'll discuss about the determination of optimum input use and optimum output to produce. So here both what is the input optimum level of input we have to use, and through that level what is the optimum level of output produced. These are the two parts which will be highlighted in the factor product relationship. Now, first important thing to know in factor product relationship is law of diminishing returns and the three stages of production. Law of diminishing returns, it describes the relationship between output and the variable input when other inputs are held constant. यहाँ पे law of diminishing returns में हम आउटपुट और एक वेरिएबल इनपुट होगा और बाकी सारे फिक्स्ड इनपुट्स हो गए. सो आवर प्रोडक्शन फंक्शन विल बी y इज इक्वल टू फंक्शन ऑफ x1, ये वेरिएबल है और बाकी सारे फिक्स्ड रहेंगे, x2 x3 डॉट नॉट अप टू xn. So this bar will separate the variable input from fixed inputs. So this is the variable resource, x1 is the variable resource or variable input. Now let us see the statement of the law of diminishing returns. If increasing amount of one input are added to a production process while all other inputs are held constant, the amount of output added per unit of variable input will eventually decrease. मतलब एक वेरिएबल इनपुट हम प्रोडक्शन प्रोसेस में इंक्रीजिंग अमाउंट में ऐड करते जा रहे हैं और बाकी सारे जो इनपुट्स है वो फिक्स्ड रखते हैं, तो अमाउंट ऑफ आउटपुट पर यूनिट ऑफ वेरिएबल इनपुट, मतलब एक यूनिट से वेरिएबल इनपुट इंक्रीज करेंगे तो आउटपुट जो है वो भी इंक्रीज होगा, लेकिन वो एक डिक्रीजिंग क्वांटिटी में इंक्रीज होगा. अभी फर्स्ट यूनिट इंक्रीज करने के बाद अगर आउटपुट 2 यूनिट से बढ़ा है तो सेकेंड यूनिट वन मोर यूनिट एडिशन से फिर से जो आउटपुट इंक्रीज होगा वो सिर्फ 1 यूनिट से होगा. ऐसे इट विल इंक्रीज बट द अमाउंट ऑफ आउटपुट एडेड पर यूनिट इट विल इवेंचुअली डिक्रीज. This is also known as law of diminishing productivity or law of variable proportion. The application of law of diminishing returns to production concept can result in production function of classical type. अगर हम classical production function को ये concept हम apply करते हैं तो हमें 3 stages of production मिलते हैं. It displays the increasing marginal returns first and then the decreasing marginal returns. So we'll see in details about the 3 stages of production. So now graphically this is the graphical representation of classical production function. And we can see this is the total TPP, मतलब total physical product. This is increasing rate up to this inflection point. Then it is increasing at decreasing rate. It will reach maximum and then it will start to decline. Then this curve, this is the marginal physical product, or we can say MP curve. This is first increasing, it reaches maximum at the point of inflection, and then again it will start to decline and it becomes negative. As APP, it is first below MPP, it reaches maximum and then it is above MPP. That is average physical product is above marginal product. So this is the three graphs: total physical product, average physical product, and marginal physical product. Then this total production function is divided into three stages or three regions. This is region 1, region 2, and region 3, or stage 1, stage 2, stage 3. So we'll see in details about this. Now there are three stages of production. A classical production function can be divided into three regions or states. Each is important, each layer state is important to know the very efficient use of resources. Now first let us see the stage 1 or region 1. It occurs when marginal physical product, that is MPP, is greater than APP. It is a region where MPP is greater than APP. So you can see here till this point, MPP is greater than APP. So this is the first stage of production. APP is increasing, that is average product is increasing throughout this stage. Average product is increasing throughout this stage and it is reaches maximum at the end of the stage. Here it reaches maximum and at this point the stage 1 will end and stage 2 will start. Now increasing AP, that is increase in average product, it indicates that average rate at which X is transformed into Y increases until it reaches maximum at the end of stage. What is AP is increasing, that is nothing but the transformation rate of X is increasing because it is formula for average product is X by Y. So here it is increasing throughout the transformation rate is increasing. Now in the second stage occurs when marginal product is decreasing and it is less than average product but is greater than 0. Second stage occurs when we say it is MPP is less than AP or AP is greater than, you can say. So this I'll show you the second region. Now this is the second region here. Point from where AP was maximum to point where MP becomes 0. So this is the second region, and in this region APP, that is average physical product, is greater than the marginal product, but marginal product is greater than 0. So this is the second region of production. The physical efficiency of variable input reaches at the peak at the beginning of the stage. That is, now physical efficiency is indicated by average product. It is maximum at the starting of the stage, but it decreases at the end of the stage. It is declining. On the other hand, physical efficiency of fixed input is greatest at the stage 2, at the end of the stage 2. यहाँ पे starting में क्या होता है, वेरिएबल इनपुट्स का फिजिकल एफिशिएंसी ग्रेटर होता है और एंड में फिक्स्ड इनपुट्स का फिक्स्ड इनपुट का फिजिकल एफिशिएंसी ग्रेटेस्ट होता है. This is because number of fixed input is constant and therefore output per unit of fixed input must be largest when the total output from the production process is maximum. Now when fixed inputs उनकी quantity same रहेगी तो उनकी efficiency कब maximum होगी, जब output per unit of input. So APP is Y by X, not X by Y by X. The average product with respect to fixed inputs, it will be maximum when output is maximum, and this is fixed inputs, the quantity remains same. So our total product is maximum at the end of second region. So at this point, physical efficiency of fixed inputs is greatest at the end of second stage. Then third stage occurs when MP is negative, and it occurs when excessive quantities of variable inputs are combined with the fixed inputs. यहाँ जो variable input है वो excess में use किया जाता है और ये MPP negative होता है यहाँ पे, and also our total physical product is also declining. So this is the three stages of production. Now we will see the relationship between the elasticity of production and the three stages. Now elasticity of production, it is given by simple formula to remember. It is MP divided by AP. Marginal product divided by average product will give the elasticity of production. Now in first stage, now we can see here as MP is greater than AP, that is denominator is greater than, sorry, numerator is greater than denominator. So in this case, our elasticity of production will be greater than 1. In second stage, it is denominator is greater than numerator. So it will be less than 0. And in third stage, MP is negative. So this here we have the negative value. Because of negative sign, our EP will be less than 0. At the end of first region and at the start of second region, at this point, our EP, that is elasticity of production, will be equal to 1, because at this point MP is equal to AP, marginal product will be equal to average product. So at this point elasticity of production will be equal to 1. So this is the elasticity of production and three stages of production. Next, we'll see the economic recommendation and production function analysis. Production function knowledge and input output prices information can be used to know the most profitable input and output level. हमें input level भी जानिए है, output level भी. तो production function की knowledge और input और output के prices, उनके द्वारा हम most profitable level of input और output decide करते हैं. लेकिन however, even when price information is not available, some recommendation about the input use can be made from production function. अगर हमें प्राइसेस की इंफॉर्मेशन नहीं भी हो तो भी प्रोडक्शन फंक्शन यूज से हम ऑप्टिमम इनपुट यूज के बारे में रिकमेंडेशन दे सकते हैं. तो पहला रिकमेंडेशन क्या होगा? इफ द प्रोडक्ट हैज एनी वैल्यू एट ऑल, input use once began should be continued till the stage 2 is reached. This is because physical efficiency of variable resources measured by APP increases throughout the stage 1. ना जो भी हम प्रोड्यूस कर रहे हैं उनमें इनपुट यूज तब तक करने चाहिए until it reaches the stage 2, because throughout the stage 1 फिजिकल एफिशिएंसी जो है वो इंक्रीज हो रही है. हमने देखा है कि एवरेज फिजिकल प्रोडक्ट हमारा इंक्रीज हो रहा है throughout the stage 1. So it is increasing. It will reach maximum during the stage 2. So up to this point we have to go on adding the input till our average product is maximum. Even if input is free, it will not be used in the stage 3. अगर हमें input freely available है तो भी हमें stage 3 में reach नहीं होना, क्योंकि जितना वो input हम use करेंगे उतना हमारा वहां पे marginal product negative हो जाएगा और हमारा total product वो decline होता जाता है इस third stage में. So we have to operate within the range of second stage, because here we have the maximum output is at the end of second stage. We have to not cross this level of input even if inputs are freely available. Stage 2 defines the area of economic relevance. Variable input use must be somewhere in stage 2, but exact input amount can be determined when choice indicators, that is choice indicators are input and output prices are known. So our optimum use level for input is, it will be between the stage 2, any input level between the stage 2. Exact level of input, it will be dependent on the price of input, but it should range between the stage 2. So this is the economic recommendation based on the law of diminishing marginal returns. Now we will see relationship between the total physical product and marginal physical product, that is TPP and MPP. Now first, since marginal product is the measure of rate of change, that is marginal product is given by change in output due to change in input. So delta y by delta, it is the measure of rate of change. So when TPP is increasing, marginal product will be positive. When total physical product is increasing, at till here it is increasing, our marginal product is positive till this point. When total physical product is constant मतलब यहाँ चेंज नहीं हुआ, तो इसका मतलब क्या हो जाएगा, हमारा मार्जिनल प्रोडक्ट इट विल बी इक्वल टू 0. एट दिस पॉइंट here TPP is constant, so at this point it will be equal, marginal product will be equal to 0. And when total physical product decreases, marginal product will be negative. Now this total physical product is decreasing and marginal product is negative. So as long as marginal product move upward, the total product increases at increasing rate. Now here marginal product, it is increasing upward till this point. So till here it is total product is increasing at increasing rate, and this is the point of inflection. Now when MPP remains constant, TPP increases at constant rate. यहाँ पे constant है, तो यहाँ पे constant rate में increase होगा total physical product. And once marginal product starts to decline, it total physical product increases at increasing rate. Increase हो रहा है, लेकिन ये decreasing rate में increase हो रहा है. And when TP will be maximum or MP will be equal to 0. So this relationship, this is the relationship between total physical product and marginal physical. Just if you remember this graph, you can tell the relationship between total product and marginal product, average product and marginal product. So this is the, to remember this, you have to remember this graph. Next is the relationship between marginal product and average product. Now when marginal product is increasing, average product is also increasing. So as long as marginal product is above average product, the average product keeps on increasing. So as long as marginal product is greater than the average product curve is below here. Average product is increasing. Once marginal product crosses average product, the average product starts to decline. So when MP curve goes below the AP curve, that is marginal curve goes below the average physical product curve, then average product curve starts declining. That is, the AP is decreasing and MP is always less than APP. So this is the second stage. Once MP cross the AP, that time AP is declining and MP is less than AP. And when MP is equal to AP, that is marginal product is equal to physical product, average product is at maximum. Here MP curve must intersect AP curve from the highest point. ये जो MP curve है वो highest point से ऊपर से intersect करता है. So this is the relationship. So we can say here, when MP is greater than AP, AP is increasing. When MP is less than AP, AP is decreasing. And when MP is equal to AP, AP is maximum. So just if you remember this graph, you can remember this relationships. Next, we have the elasticity of production. So elasticity of production, it measures the degree of responsiveness between the output and input. So it measures the change in output because of change in input. So formula it is percentage change in output divided by percentage change in input. So you can see here, elasticity of production, it is greater than 1 in stage 1. It is between 0 to 1 in stage 2, and it is negative in stage 3. This is based on the values of marginal product and average product. The point of diminishing returns can be defined to occur when marginal product is equal to average product and elasticity of production it is equal to 1. And this is the lower boundary of stage 2, that is at the point where stage 2 begins. So this is the point of diminishing returns. And this is the minimum amount of variable input that will be used, and it occurs when efficiency of variable input is maximum. This level is the minimum amount of variable input to be used for efficient output production. And at this point, the physical efficiency of variable inputs will be maximum. At the other end, MPP is 0. So at the end of the second, MPP here it is equal to 0. And at this point, physical efficiency of fixed inputs will be greater because here total physical product is highest. So thus the relevant production zone is when elasticity of production it ranges between 0 to 1. So यहाँ पे 0 है, यहाँ पे 1 है. So this is the relevant production zone. The optimum level of variable input is given by delta x1, that is the change in x1 into price of x1, which is equal to delta y, that is change in output into price of output. Or we can say it is as delta x1 divided by delta y is equal to price of y divided by price of x1. That is nothing but marginal cost is equal to marginal revenue. We can say in other terms, it is a point where marginal cost is equal to marginal revenue. Then we have next factor-factor relationship. In factor-factor relationship, we are concerned with the possibilities of substituting one input to another input for producing given level of output. Factor-factor relationship में क्या होता है? Output जो होता है वो फिक्स हमें दिया होता है, इतना आउटपुट हमें प्रोड्यूस करना है, तो उसके लिए जो दो इनपुट्स है वो सब इनपुट्स किस कॉम्बिनेशन में यूज करना वो हमें डिसाइड करना पड़ता है. So how at what level one input should be substituted for another input to achieve the given level of production. This is this problem is solved in factor-factor relationship. It answers the crucial question of finding out optimum or least cost combination of two or more resources in producing given amount of output. जो भी आउटपुट प्रोड्यूस करना है उसमें लीस्ट कॉस्ट कॉम्बिनेशन कौन सा है जिसमें दो इनपुट्स हम यूज कर सकते हैं, उसे ये प्रॉब्लम यहाँ पे सॉल्व होते हैं. The two-fold object of factor-factor relationship is, first one is minimization of cost at given level of output and optimization of output to fixed factor through alternative resource combination. These are the two objectives. First objective क्या है? वो minimum cost level of input find out करना है जिससे हम given level of output produce कर सकते हैं, और optimum output produce कर सकते हैं जिससे through fixed factors based on the alternative resource combination. So functional relationship here we can express the production function as y is function of x1 and x2. These are now variable resources, and other resources like x3, x4 up to xn, these are the fixed resources. So this is the mathematical representation of factor-factor relationship. Now in factor-factor relationship there are different concepts we use. First concept is the isoquant, or it is also known as isoproduct curve. It is defined as locus of various combination of two inputs yielding same level of output. Isoquant क्या represent करता है? Various combination of two inputs जो same level of output produce करे. This is the same concept as in case of indifference curve in case of कंज्यूमर थ्योरी में जो हम इंडिफरेंस कर्व स्टडी करते हैं उसका ही अगर हमने प्रोडक्शन में अप्लाई किया तो वो आइसोक्वांट होता है. Each point on isoquant represents the maximum output that can be attained with the use of this input combination. Now here you can see this isoquant gives the represents the 10 quintals of production. Next will represent 20 quintal. This will represent 30 quintal. Likewise, each isoquant will represent same level of, throughout this isoquant, the output level will be same. Now, isoquant is convenient device for compressing 3-dimension pictures into 2 dimension. यहाँ पे जो isoquant में क्या हो जाएगा? 3 dimension जो है वो 2 dimension में express किया जाता है. For example, here now we have 3 dimensions. What are our dimensions? First one x1, x2. These are the 2 inputs and our output y. Now here, as for each isoquant, output is constant, so it is considered as y0 because it is constant. So we can express it as isoquant as x1 is function of x2 and fixed output. So this is the mathematical representation of isoquant. Then properties of isoquant. As like indifference curve, isoquant also has same property. First property, it is negatively sloped. You can see here in the curve it is negatively sloped. It is decreasing from left to right. Isoquant to the right indicates higher level of output. That is, as we move farther away from the origin, it indicates higher level of output. Now, isoquants do not intersect each other. Isoquant cannot intersect each other because each isoquant shows the different level of production. So, if they are intersecting, that means it is showing the same level of production, which is not possible. Now isoquant is convex to origin showing the diminishing marginal rate of technical substitution. जो ये convex to origin है because of diminishing marginal rate of technical substitution. Now types of factor-factor relationships. There are many types of production surfaces are possible depending on the production function. So the shape of isoquant and production surface, that is production function, will depend on the manner in which variable inputs are combined to produce the particular level of output. जो भी isoquant का shape है वो किस पे depend होगा, जिस combination में variable inputs combine किए जाते हैं to produce the given level of output. So there are, broadly we can say there are three categories of combination of two inputs. First is fixed proportion combination, that is fixed proportion मतलब one unit of x1 needs 1 unit of x2, that is fixed proportion. Then constant rate of substitution and varying rate of substitution. These are the three categories in which inputs can be combined. So let us see in detail one by one. First is fixed proportion of combination. This represents such products that can be produced if inputs are added in fixed proportion at all level of production. जो भी प्रोडक्शन लेवल है उसमें फिक्स प्रोपोर्शन में ही उसे इनपुट्स लगेंगे तो उसे हम फिक्स प्रोपोर्शन कॉम्बिनेशन कहते हैं. In this case there is no substitution between the input and thus there is strict complementarity, that is two inputs are complement relationship is seen in the two inputs, and such isoquants implies that one exact combination of input will produce particular level of output. एक यहाँ पे एक ही कॉम्बिनेशन पॉसिबल है होता है और अगर कोई हम वहाँ चेंज करते हैं तो वो चेंज पॉसिबल नहीं होता. फॉर ईच लेवल ऑफ आउटपुट ओनली वन कॉम्बिनेशन ऑफ इनपुट इज पॉसिबल. द इनपुट्स which increase the output only when combined in fixed proportion. These are known as complementary inputs. यहाँ पे एग्जाम्पल क्या है, फॉर इन केस ऑफ फिक्स प्रोपोर्शन कॉम्बिनेशन अगर हमें पाया गया तो वहाँ पे इनपुट्स क्या होते हैं, वो कॉम्प्लीमेंट्री इनपुट्स रहते हैं. फॉर एग्जाम्पल वन ट्रैक्टर एंड वन ड्राइवर. सो नो प्रॉब्लम इन इकोनॉमिक डिसीजन ऑफ वर्किंग. दिस इज ऑल्सो कॉल्ड एज लियोनटिफ आइसोक्वांट. यहाँ पे अगर हम एक ट्रैक्टर है तो हमें एक ड्राइवर का, अगर हमने और एक ट्रैक्टर लिया तो उसके साथ और एक ड्राइवर हायर करना पड़ेगा. तो दिस इज द फिक्स प्रोपोर्शन. फॉर एवरी ट्रैक्टर वी नीड वन ड्राइवर. सो दिस इज, देयर इज नो अदर पॉसिबल कॉम्बिनेशन. हम ये नहीं कह सकते कि दो लोग एक ट्रैक्टर को चला सकते हैं या दो ट्रैक्टर एक ही ड्राइवर चला लेगा, ऐसा नहीं होता. फॉर ईच ट्रैक्टर वी नीड वन ड्राइवर. सो दिस इज द फिक्स्ड प्रोपोर्शन कॉम्बिनेशन and it is called as Leontief isoquants, and the shape of isoquant is L shape. Here it is indicated by, this is the 1 unit of tractor, 1 unit of labor. Again, if you double it, when you take 2 tractors, you need 2 drivers. So this is the Leontief isoquants. Next we have the, we'll know about the substitutes and complements. When two resources are said to substitute, when the change in price of one leads to change in demand of other, then we call it as the substitutes. And when resources are used together in the production process, these are the complements. When price of x1 increases, the demand for x2 decreases. This is the complement. So there are two types of inputs, substitutes and complements. Substitutes are one which, because of change in price of one, leads to change in demand of another. And complements here, जो भी एक इनपुट की प्राइस इंक्रीज हुई तो डिमांड फॉर अदर डिक्रीज होता है. सो दीज आर द कॉम्प्लीमेंट्स. The second type of relationship is factor-factor. We have constant rate of substitution. Such type of factor-factor relationship gives the linear isoquants. The substitution occurs at the constant rate. That is, amount of one input replaced by another input does not change as added input increases. यहाँ पे यहाँ पे सब्स्टिट्यूट्स रहते हैं, दो इनपुट सब्स्टिट्यूट्स है. फॉर एग्जांपल वी कैन से फॉर नाइट्रोजन, द क्रॉप नीड्स नाइट्रोजन, सो द टू सोर्सेस ऑफ नाइट्रोजन इज यूरिया एंड द ऑर्गेनिक मैन्योर. So these can be substituted for one another. If we go on increasing urea, we have to decrease the organic content, or if we are increasing the organic content, we have to decrease the urea. So these are not the example for perfect substitutes, But when the case of perfect substitutes, the isoquant line is straight line declining from left to right. And when there is substitute, they are not perfect substitute, but there can be some level of substitution. Then the isoquant curve will be convex to the origin. Now we are speaking about the constant rate of substitution. So this substitution for x, suppose there are two inputs x1 and x2. Now if we increase the units by, suppose we are increasing the x1 input, then in same way if we are same level we decrease the level of x2 input. So we can say here marginal rate of substitution is equal in constant rate of substitution. Next we have varying rate of substitution. This is in this if they are not perfectly substituted, they are non-perfect substitutes. So in this case, we can see varying rate of substitutes. In this, there are either can be increasing rate of substitution or decreasing rate. The marginal rate of technical substitution varies over the isoproduct curve, that or we can say isoquant. It means that amount of one input required to substitute for another input at a given level of production increases or decreases as amount of x1 used increases. The substitution and decreasing rate it is common in agriculture. जो भी substitution वो decreasing rate में हो तो वहाँ this is the commonly found in agriculture and it can be expressed as delta x2 x21 divided by delta x1 x11. This is the x2 for first combination and x1 for first combination. It is greater than change in x22 divided by x12. So here even though if this is decreasing rate, here sign will be increasing. Now for this relationship there are convex isoquant. Convex isoquant represent the continuous substitution between the two inputs and this can be mathematically represented as MRTS, that is marginal rate of substitution for x1 for x2. It is given by delta x2 divided by delta x1. So this is the varying rate of substitution. Next, we'll see the definition of marginal rate of technical substitution, or it is known as MRTS or also only known as MRS, marginal rate of substitution. It is defined as negative slope of isoquant at any point. MRTS is the negative slope of isoquant. It is the rate at which two factors of production can be exchanged at a particular level of output and consequently that levels of input used. यहाँ पे it is rate at which one factor is substituted for other factor to maintain the same level of production in simple language. So it is nothing but the slope of isoquant. So slope of isoquant is equal to MRTS, that is marginal rate of technical substitution, which is equal to delta x2, that is change in x2 divided by change in x1. Here x2 is the replaced product and x1 is the added product, or we can say it is equal to marginal product of x1 divided by marginal product of x2. So you can simplify it as dy is equal to dy, that is differentiation with respect to x1 into dx1 plus differentiation of y with respect to x2 into dx2. Now dy is equal to 0 because it is an isoquant. Here production is constant. So this will be dy will be equal to 0. So we can say that if we simplify this, we'll get minus dx2 divided by dx1, which will be equal to dy divided by dx1 whole divided by dy divided by dx2. That is nothing but this is the marginal product of x1 and denominator is marginal product of x2. So we can say that slope of isoquant, that is marginal rate of technical substitution, is equal to the ratio of marginal physical products of x1 and x2. So this is the marginal rate of technical substitution. Next we have the isocost line. The next concept is factor-factor relationship. Now isocost line, it represents locus of all possible combination of two inputs which can be purchased with the given outlay or budget. जो भी farmers के budget है, farmer का income है, उसमें हम पॉसिबल कॉम्बिनेशन ऑफ टू इनपुट्स कितना परचेज करते हैं वो इंडिकेट करने के लिए हम आइसो कॉस्ट लाइन इंडिकेट यूज करते हैं. Suppose that T is the total income or budget of the farmer, then that will be equal to price of X1 into quantity of X1 plus price of X2 into quantity of X2. So if we rearrange this, we'll get X1 is equal to, now if we rearrange, this will get into this will move towards the left hand side, so it will be T minus price of X2 into the quantity of X2 whole divided by price of X1. So this is the equation showing the iso cost line, and this is the graph showing the iso cost line. Here now, this line shows the combination of X1 and X2 inputs that can be purchased at the given level of input. Now, 2 points that important points regarding the ISO. If the prices are same and only the income or total budget is changing, the ISO cost line will be parallel to each other. Now, suppose ये इनिशियल लेवल के ISO cost line है, और अगर फार्मर्स का बजट इंक्रीज हुआ तो ये पैरेलल शिफ्ट towards the right होगी, which is farther from the origin, and if budget of farmer decreases, it will move towards the left, that is towards the origin. So if only there is no change in price and only income is changing, then there will be parallel shift. And if the prices of input is changing, the slope of iso cost line will change. For example, now if we take this is our initial iso cost line. Then suppose if price of X1 decreases. Now our new iso cost line, it will move in anti-clockwise direction. That is, this is anti-clockwise direction. It will move outwards, and the slope of the iso cost line changes. And suppose if price of X1 increases, it will move inward, or it will move in clockwise direction in this way when the price, and it becomes more steeper. So this, when price of inputs changes, the slope of iso cost line will change, and when the income increases, there will be just a parallel shift in iso cost line. So we'll find out the least cost combination. Aim of factor-factor relationship is to find out the least cost combination of inputs. Now we have two factors, isoquant and isocost. Now the slope of isoquant is MRS X1 for X2 is equal to delta X2 divided by delta X1, and slope of isocost line is the price ratio, that is nothing but price of X1 divided by price of X2. Now least cost combination, it is the point, least cost combination is obtained at the point where the isoquant is tangent to isocost line. So that at the point of tangency, the slope of isocost and isoquant is equal, that is nothing but MRS or MRTS will be equal to price ratio, that is nothing but delta X2 divided by delta X1 is equal to price of X1 divided by price of X2. Now if we simplify this, we will get price of X2 into change in X2 is equal to price of X1 into change in X1. I'll write it here. That is nothing but price of X2 into change in X2 is equal to price of X1 into change in X1. Now suppose if the price of X1 into change in X1 is greater than price of X2 into change in X2. In this case, to bring it to equal, we have to increase the X2 level of input. And if price of X1 into change in X1 is less than price of X2 into change in X2, at that time we have to increase X1 to bring it to the equal level. So graphically we can say least cost combination, it is at the point where slope of isoquant is equal to slope of isocost line, that is at the point of tangency where isocost curve is tangent to isoquant curve, that is the least cost combination. So next we have the concept isocline and ridgeline. Now isoclines, these are the lines or curve that passes through the points of equal marginal rate of substitution on isoquant map. Now this is the isoquant map. We have the different isoquants here. This is the isoquant map and isocline. These are the line which joins the equal marginal rate of substitution or equal slope of various isoquants. So at this point on higher successive isoquants, the slope of isoquant is same. So if we join these points from origin like this, we'll get the isocline. So likewise here also, these are the slope of at this point is equal. So this is the isocline. So we likewise we can have number of as many slopes of isoquant, that many number of isoclines. Now, particular isocline will pass through all isoquants at the point where isoquants have specified slope or equal slope. There are many different isoclines as there are different slopes or marginal rate of substitution on isoquant. The next concept we have the ridgeline. Ridgeline represents the limit of the economic relevance. As the name, ridge means it is the limit of economic relevance. These are the boundaries beyond which isocline and isoquant maps have no economic meaning. So these are the lines beyond which there is no economic meaning. Only between these two lines there is the economic region, and beyond that there is an economic region. So on the ridge line, marginal product is 0. So if these are the two ridge lines you can see here. These are the two ridge lines. So at this line, the upper ridge line 1, the marginal product of x2 is 0 at this point. That is MP2 is equal to 0 on upper ridge line, and under the lower ridge line MP1, that is marginal product of x1 is equal to 0. The ridge line denotes the limit of substitution. Outside the ridge lines, inputs do not behave as substitutes, they become the complementary. So only within this range they behave as substitutes, and beyond this they behave as complements. So this is the economic region within which substitution has to be made. Next is the expansion path. Expansion path, it is a type of isocline which connects the least cost combination of inputs on the all output levels. So each isoquant will represent different output level, and every cost line it represents the higher budget. So the point of intersection of successive isocost and isoquant line, if we join this, we get the expansion path. So expansion path is a curve which joins the least cost combination of inputs at all the yield levels. On expansion path, marginal rate of substitution will be equal to the input price ratio, and any particular time there is only one expansion path possible. At any one situation, there is only one expansion. There are a number of isoclines, but expansion path is only